Today we're going to be constructing parallel lines. The first one is constructing parallel lines from congruent corresponding angles. And because these are constructions, we expect to really only use these two tools: a straight edge, doesn't have to have any measuring tools on it, and then a compass. I'm going to begin by creating a line. This is the line that I want to go parallel to it. In order to do this, I'm going to need a transversal. So I'm going to draw myself a transversal. In concept, what I'm aiming for is I'm going to end up with a line going in here that's parallel to this one. To do that, I'm going to get congruent corresponding angles. Do you agree that in general, corresponding is where they copy, paste, and match up? So like this angle up here would match up with this angle here. So what I'm looking for is a way that this angle and this angle through this imaginary line so far match up. Would you say that the corresponding angles here are congruent at this point? We need to make that look more like a line. If I compare this angle here to this angle up here that's corresponding, are there going to be congruent corresponding angles? No. What if I go up like this? But if I can make it exactly parallel, do you agree that the corresponding angles will be congruent? So we're going to use the converse of that. We are going to demonstrate that this angle and this angle down here, put a dot here and make a little X to show that the other angle is going to be up there relative to that dot. And I'm going to copy this angle up here down here. By doing that, it's going to give me the ability to draw a line through those points that would give me lines that are parallel. Step one, if we're going to use a compass, notice that it's got this very sharp tip. If I try to put it into the paper now and it's on top of this desk, it's going to slip all over the place. And eventually the paper will tear and it'll be a mess. So you should always put your paper on top of a stack of other papers, or on top of a binder, or on top of a textbook. You should have something underneath here that's going to let your needle stick in. And if you need scratch paper, I got a stack of over there, but I think that would be an excellent idea. Not. Okay. I do, but we're recording. Let's just let this go. All right. So here's what I'm going to do. I am going to create a reference arc. I'm going to start with my needle at this yellow point, and I'm going to choose some side length, in other words, how big my compass is, so that it fits. It goes across both of these rays that form this angle. Doesn't matter the size, as long as I can see it intersect both the transversal, this one, and the line that's going to be parallel. Whatever that size is fine. But once you make this reference arc, don't change your compass. We're going to keep that same radius length in here, and we're going to do it to this dot that we placed somewhere down here in our transversal. Right on that dot, and then make another arc. It's a copy. And so you'll notice that up here, this arc was going through the transversal, and then it's going through the parallel line. Now over here, it's going through the transversal, and it would go through the parallel line once we draw it. We just don't know where that is. So I need to figure out exactly how far away these two endpoints are. This point where the arc crosses my transversal, and this point where the arc crosses my parallel line. I'm going to use my compass to measure that. So I put my needle right at that point of intersection, and then I use the wheel to open up my compass until it's just the right size so that when I draw an arc, it goes through that point of intersection. And I should leave that mark there, showing me that this is where I copied the length from.
Wait, can you repeat that?
Yep. I'm going to put a needle on this point, the intersection of the arc and the transversal.
Okay.
And then I open up my compass to just the right side so that I can make this mark, showing the other intersection of the arc with this parallel line. Now I'm going to take that measurement that I just got and I'm going to bring it down here. And I'm going to say, all right, I need to do the same thing here between this point of intersection and somewhere out here is the other matching one. I need this to find it. So I put this right on that intersection of the arc and the transversal, and I make an arc. That little point where this arc and this arc meet is the golden spot. I want to draw from this point, which was the vertex, exactly through that point of intersection. And in doing so, I should end up with a line that is parallel to my first line. Why is it parallel? Because I produced corresponding angles that are congruent. And what that gives me is the ability to say that these two lines are parallel. And now let's write it as an if then. What's the conclusion? What were we trying to create here? Parallel lines. And what were the conditions we had to have in place to be able to make that happen? Yes, we did need corresponding angles. And before we could have corresponding angles, we had to have a transversal, because that's what made them, right? And with the transversal and choosing to have corresponding angles, we force those corresponding angles to be what relationship? Congruent. So if transversal corresponding congruent, then the lines are parallel. Okay, second one. For this one, we're going to be constructing parallel lines from congruent AIA. What does AIA mean? Good. Alternate interior angles. And as a graphic, where would that go? Like maybe there and there. Those look like alternate interiors, don't they? So let's give ourselves our starting situation. We need one line that we're going to create parallel to it. And we need a transversal. And let's put a point on the lower part down here. It's pretty far near the end. And the scale is actually exactly the same scale. We're going to copy this angle and put it here. But which angle are we going to copy? Angle 1, 2, 3, or 4? 3, right? We could do 4, but the way I've drawn the picture there, I'm going to do this one. So that means I'm going to go from this vertex, and I'm going to make a reference arc. As long as it crosses over both those sides, I'm good with it. And then where am I going to put that? A, B, C, or D? If I want them to be alternate interior angles, B, right? I want to draw it so that it goes from here all the way down, creating an angle space for B over here. And then these will be alternate interior angles. Now, depending upon your size and your orientation of your transversal, you may have these two arcs, like mine, overlapping, or they could be missing each other, or they even could fall on the same point. Sometimes that happens and it looks very weird. Like this is what we did on third period. It fell together in the same point, which is coincidental. All right. So now what we need to do, we've got the same arc for both of them. We need to find out how big the mouth is here. In other words, we're measuring from the transversal to the parallel line, and we'll copy that down to go from the transversal to the parallel line. So I'm going to actually go, from the transversal, adjust my size so that it catches the right spot, and leave a mark there showing that you took it from there. There should be a pencil mark there. And then I'm going to take it and install it here on this blue point of intersection. But I want to catch it down on this arc. Let me do that again. I use my compass from the top reference arc where it meets the transversal and open it up using the wheel to be just the right size from this line to this line where they meet the arc. Then I pick up my compass, keeping it the same size, and insert it into where the other arc meets my transversal and make a mark along that arc. That's what this thing is. If I connect my vertex to this point of intersection of these two arcs, I expect to produce a line, as any two points are collinear, and that line will end up being parallel. The reason it's parallel is because this angle and this angle that are in that AIA relationship are congruent. And thus these two lines are parallel. Say again? It's a form of proof, isn't it? It's different than a two-column proof. Yes, we'll have two-column proofs of these same theorems. Yes, Alex? Excellent question. Alex is asking why I used one arrow here and two arrows here. And the same question would be why I used one hash mark here and two hash marks here. And the answer is, if I chose to use one hash mark here and here, I'm saying those two angles are congruent. And since this is really like the same document, if I put a one hash mark here and a one hash mark here, I'm not just saying these two are the same. I'm actually saying that all four of these angles are the same. And I'm not trying to do that because I didn't make them that way. Similarly, if I use one arrow here and one arrow here, then I'm saying that this line, this line, this line, and this line are all parallel. Instead, now I'm saying these two that match as two arrows, these two are parallel. I don't know about those.
You do like four.
Yeah, we're going to do a third and a fourth one now. So we're going to have to use 3 and 4, right? Okay, let's put in our if then. What's our conclusion here? Parallel lines. And what were the conditions necessary for us to be able to achieve those? Transversal. What kind of angles? AIA, and we need those angles to be congruent. And if they're congruent, then the lines become parallel. Okay, third one. Constructing parallel lines. From congruent AEA. What does AEA stand for? Yep, alternate exterior angles. And again, we begin the same way. And let's give ourselves a little picture of where we expect these alternate exterior angles to be. Those look like alternate exteriors, don't they? So let's put an X up here. Which angle should we use here? Top left? My picture says top right. We could use top left, but I'm going to use that one. Now, since I'm using that one, should I put my dot close to the first line or way down at the bottom as my vertex of the second? Closer, because I need room on the bottom, right? So let's put it like there. And my X, my new angle, is going to be down there. Step 1, reference arc. So from here, I make sure that I choose a big enough radius that it hits both sides. Step 2, pick that up and do the same on the other angle. And now I'm going to find out how far apart those two points of intersection are. And then I'll do the same thing here to go from this point of intersection up to somewhere up here. Sure to leave a mark showing where you copied it from. And leave a mark showing where you put it. Connect the dots. Okay, how should we mark this thing? Yeah, let's put 3 hash marks. So we're not saying it's congruent to these other ones, but it's congruent to this other one with 3. And then let's put 3 arrows to say that these lines are parallel to each other. And we've got an if then. What's our conclusion? Parallel. What are our 3 conditions that are necessary? Good. Transversal. What kind of angles did we do? AEA and congruent. How are we feeling? 5, this is really easy. I can do this. 3, I'm following along, but I won't be able to do this on my own later. 1, I'm struggling and I keep poking myself. Ouch, it hurts. Okay, good. All right, 4th one. Construct parallel lines from perpendicular to perpendicular. This time, do not draw yourself a transversal. We're only creating one line. Now, we've done this before. We've constructed perpendicular. In fact, it was called a perpendicular bisector then. Remember how we did that?
Yeah.
We chose some 2 points and made the football in between them, more than halfway. But that would be a perpendicular bisector. We're not concerned with the bisector portion. So I'm just going to pick 2 random points along my line here. And I'm going to put my needle into one of the points and adjust my compass so that it is more than halfway over to that point. And I'll make an arc. Random points. And then I'm going to do the same thing from this other side. What would happen if I didn't go more than halfway? What if I went less than halfway? These 2 arcs wouldn't meet. I'd have no points of intersection. This then creates 2 points of intersection. And if I connect those, I should produce a line that is perpendicular to my first line. Now, you guys ready for the advanced maneuver? Here we go. Watch carefully. Oh, oh, oh. Turn your paper 90 degrees. And we're going to do again right here. So just pick 2 points and construct another football between them. More than halfway. And connect to those endpoints. Oop. Picked up my thing too fast. Now let's work on the if then for this. What's our conclusion? What's our conclusion? Parallel lines. Now, these 2 angles that I've produced, what's their relationship? What's the named pair relationship? Lines are parallel, angles are not. What do you call these 2 names? Are they alternate interior? Are they alternate exterior?
Same side interior.
Same side interior. So we're saying that if the transversal forms SSI, now before you write congruent, it's true that these are congruent, but I actually made them special because how big is each one? What's their measure? 90. And if you add those together, what does it make? They're supplementary. That's the more important part. Yeah. This means perpendicular, and this means perpendicular. So I made one perpendicular line, and then to that line that was perpendicular, I made another perpendicular. What? Just, yeah. Hey, Bennett, I can't hear the questions. Please try again, Camille. Did you have a question? Okay. All right. Your homework tonight has 2 parts to it. The first part is to do this exact same thing, except titled Homework 21. Exactly the same thing. So when you ask if you should write the same thing, should you mark it the same way? The answer is yes. All the same. Say again. Gentlemen, I'd love to hear the questions being asked, but I just can't. Hold on one second. The second part of the homework comes from something I experienced recently. Now, I recently got engaged. I now have a wonderful woman in my life who happens to be very passionate about and loving of her Jewish heritage. And this is new for me. I didn't grow up Jewish. And so the other night I went to a service for Yom Kippur. And my understanding of this is that it's about a day of atonement. And it's about taking a year and saying, okay, I made it. And some things I did well, and some things maybe I'm not proud of. Maybe I would like to be forgiven for those things. And I'm not looking for the religion side of this, but I think there's power in accepting responsibility for things you did poorly in the last year and choosing to step forward and do things differently this year, having a life of intention. So the second part of your homework is to answer the question, who are you? Now, when you answer this question, there's a bunch of components. We've talked about congruence versus equality. Congruence has a ton of different elements. You have a ton of different attributes. I want you to pick five things that describe you. And you must pick things that are big enough that they encapsulate all of you in just five. They could be sports that you're into. They could be the fact that you're an athlete. They could be a descriptor like intelligent or clever or funny. They could be a noun that is something you consistently call yourself, right? A student, curious, warm, caring, helpful. I want you to come up with 5 terms that identify who you are and just have them written down for Monday. Okay, so finish this page that you should probably do here while you've got a compass and tell me who you are in 5 terms. Okay, all right, you can get to work.
Are you gonna do it